All right, everyone, welcome to the part 3 video on solving quadratics using factoring. I'm going to talk about two unique cases. This is kind of just as we get progressively into part 3, you'll notice the equations are a little bit more difficult. Okay, so I just wanted to hit kind of these two situations and some tricks that may help you solve possibly these larger numbered ones there. Okay, so let's take a moment. I'm going to start out like I usually do. I recognize that equals 0, so I don't have to worry about getting everything over to one side. And then I'm going to try to find two factors of a times c. So when I look at this, I say, all right, 20 times 16. So I need two factors of, let's see, 320 that would equal 36. Okay, so right now I'm like thinking, oh man, this is not going to be a good one here for me. But let's take a step back now. Now, if I get a product that's such a large number that it's really not something that I see on a regular basis, what I can do is then look at the coefficients. Is there something that I could factor out that would make this an easier problem? And if we look at all the coefficients, the 20, the 36, and the 16, you'll notice that 4 is all a factor of those numbers. So what we can do is what we call factoring out of 4. And so we divide each of the coefficients by 4. So 20 divided by 4 is 5. And then we have 36 divided by 4 is 9. And then 16 divided by 4 is 4. All right? And so now all I've done is, again, divided all of the coefficients by 4. You'll notice that it's on the outside. Again, if I were to distribute this 4 back out, I would still end up with the same thing. But now if you look at it here, if I divide both sides by 4, that would cancel this out. And I would divide this side by 4. And the convenience of having it equal 0 is that 0 divided by 4 is 0. So now I have a new terms to deal with, a little bit smaller in nature, that I can take 5 times 4, which is 20, and two factors of 20 that when added together equal 9. That's a lot easier than my 320 that would equal 36. I feel a little bit more comfortable now. So quickly, let's see. Two factors of 20 that would equal 9. Right off the top of my head, I got 5 times 4. And so I'm going to write those as two binomials. Okay, and then I'm going to divide by a, this front number here. So if I divide both of them by 5, all right, then I take, let's see, x plus 1 and 5x plus 4 equals 0. And then I'm going to, because again, you've probably gotten used to me saying this now, zero product property. So if I make one of these equal 0, then it really doesn't matter what the other binomial equals, because anything times 0 is 0. So if I want to quickly do this one, I get x equals -1. And this particular case, I'm going to go to my last video and just quickly do this. What would be the opposite of positive 4/5? That would be x equals -4/5. And you can again prove that by setting 5x plus 4 equal to 0. And those are my two solutions. So again, to recap what I did, I noticed when I took the product of a times c, it was sort of a large number and not something that I'm comfortable in finding the factors with, because it would take a little bit of time. And so then I went back to the drawing board and looked at the coefficients and found a common factor that they could all be divided by, which in this case was 4. And then I solved the problem, got rid of the 4, and I had a much easier coefficients to deal with. So a times c was 20, and so on and so forth. This is still the same answer. Let's say you didn't recognize this and you spent the time finding factors of 320 that equal 36, and you went through the same process we did, you will get the same answer. It just might take you a little bit more time to find those factors. All right, now let's look at this beautiful problem over here. And I want to point out right here is the equal sign. It's important you recognize where that is right away and not just get going and say a times c and thinking that 6 times 5 is a times c. Recognize where the equal sign is. Now you'll notice throughout this whole lesson I've been talking about it has to equal 0. So we can't start the solving process until the quadratic or polynomial of any degree equals 0. So I need to go through the process of moving everything over to one side. Now again, I've reiterated the fact that I like to keep my a positive. So I'm not going to do minus 6x squared over here. I'm going to move this 4x squared over to here. Okay? Again, there's nothing wrong with minus 6x squared. You can see the 2 terms over here, 3 terms over here. But just for my comfort level, I like to keep my a positive. Okay. Now I'm going to take this step by step here so you can see my solving process. So what I just did is I moved the plus 4x squared over here. He combines with the other x squared to make 10x squared. And then I'm going to move over this 5x minus 5x minus 5x, and we get 10x squared minus 15x equals negative 5. Okay. And my last and final step is I need to move this 5 over here because I need to have the quadratic equal 0. So again, I have 10x squared minus 15x plus 5 equals 0. All right. So I've accomplished my goal. The quadratic equals 0. So now I can start that factoring process. Okay, so I take 10 times 5, which is 50. And I need 2 factors of 50 that will equal negative 15. Now, for the sake of my example I just did over here, I'm going to say, I'm not sure about my factors of 50, which you probably are, but I do notice, so I look at all the coefficients and I see that they're all divisible by 5. So I'm going to factor out a 5 and divide all of the coefficients by 5. Again, if you didn't recognize this, you're still going to get the same answer. In fact, you could probably not have to worry about this, but I just want to prove that fact in case you did not factor out a 5. So now we got 2 times 1, which is 2. I need 2 factors of 2 that when added together equal negative 3, and those would be negative 2, negative 1. And I'm going to write those as 2 binomials. And then I'm going to divide by a. So I'm going to get a by divide by a, and I get x minus 1 and 2x minus 1 equals 0. Okay, so the finishing touch here, again, if you've watched my videos in the past, you see that I know that that's going to be x equals 1. And if I look up here to this fraction 1, what's the opposite of negative 1/2? And that's going to be positive 1/2. So x equals 1/2. And so those are my 2 solutions to the problems. I would say this is probably as advanced as it gets. I mean, we can't really get any more. I could put more terms in it, combine like terms, but the nuts and bolts of this whole process is setting it equal to 0, factoring it, setting the fine binomials equal to 0, and solving. So thank you for watching the video.